Hi everyone, welcome back to the channel. And for those who are new, welcome to the channel. In this video, we're going to be looking at the multiplication of matrices. So there are two ways in which multiplication applies to matrices. And the first is the multiplication by a scalar. The second we're going to look at is how do you multiply two matrices together. So multiplication by a scalar, what you're looking at is a scalar is just like one value, right? One number. So in this case, we have an example where you've got 4 multiplied by this 2 by 3 matrix. And the way we do it is that scalar value, that 4 value, gets multiplied by each of the elements in the matrix. Here we go. Okay, so you see also that the order of the matrix you started with remains the same. And that is not the case when you multiply two matrices together. So let's have a look at that one. So the multiplication of two matrices, what you're going to be doing is you're going to be taking, see here you have 2 by 3 multiplied by a vector, right? Vector is just a single row. The way we multiply two matrices together is we're going to take the first row multiplied by the second matrix. And I'm just going to write it out and then do the computation afterwards. So it's going to be 4 times 8 plus 7 times 5 plus 6 times 9. Right, so that will be the first element of your final matrix. Then we go 2 times 8 plus 3 times 5 plus 1 times 9. Right, so what we're doing is we're moving in this direction multiplied by that direction over there. Okay, and that is going to simplify to the first element is going to be 121 and the second element is going to be 40. Right, so you can see also, unlike when you're multiplying by a scalar, in this case when you multiply two matrices together, the final order of your matrix is going to be different. So here you have a 2 by 3 multiplied by a vector, which is a single row, which is a single column in this case, and you end up with another vector, but you've only got 2 rows as opposed to 3 rows over here. Okay, so if I write it in summary, right? So in summary, if I had vector A, say I had a matrix A, right? And it was A11, A12, A13, A21, A22, A23. And you have a vector B, B1, B2, B3, right? Then A times B is going to be that A11 times B1 plus A12 times B2 plus A13 times B3, right? And then the next row is going to be A21 times B1, and that's going to be A22 times B2, A23 times B3. Right, and that's what it's going to look like. Okay, so this is multiplying a matrix by a vector. Now let's look at a bigger matrix. This one becomes more complicated. Okay, so say for example, we just take one Yeah, so say I have a matrix 1, 5, 2, 7, 3, 4 times 8, 4, and 3, 2, 5, right? So the way we're going to do that is the same, right? So we're going to look at, in the first position, your final matrix here, it's going to be 1 times 8 plus 5 times 2. Then in the next position, it's going to be 1 times 4 plus 5 times 5, right? So what we're doing is we're going this one times that one gives us this one here, right? Then the next position, that one times this one gives you that one there. Now, so then the next one is going to be 1 times 3, 5 times 8.
A few moments later.
And this is what you do for each of the rows of the first matrix, right? So the next position you're going to have is going to be with the next row, which is the 2, 7, the 2 and the 7 with the elements, right? So we're going to have 2 times 8, 2 times 8 plus 7 times 2. Then you have the same row with the next column. So it will be 2 times 4, 7 times 5. Right? Next position you do with this blue one here, where the blue arrow is. So it will be 2 times 3 plus 7 times 8. And the last one will be, what is it? 2 times 1, 7 times 6. And then the final one is going to be your final row, which is going to be 3 times 8 plus 4 times 2. 3 times 4 plus 4 times 5. And then this one will be 3 times 3, 4 times 8. And 3 times 1, 4 times 6, right? So you can see how tedious this can get if you get matrices of really large sizes, which is why you use software in order to do these calculations, right? It's really easy to make a mistake by hand. And that's what makes like MATLAB, Octave, Python, it's what makes those programs so very powerful, especially when you're doing numerical analysis and you're working with really, really large matrices. When you're using things like finite element analysis, you're also just using software that are able to handle really, really large matrices. So your answer here is supposed to be, and I'm just going to write it down because I'm not going to add all of this while on camera. Number one, I might make a mistake, probably would make a mistake. And number two, it'll just take too much time, to be honest. So what we'll get is, the first one is 18, 29, 43, 31. Right. And then 30, 43, 62, 44. Let me just get myself out of the way here so you can actually see what I'm writing. There you go. And then the last one is 32, 32, 41, 27. Right, and that's what you end up with. So now you can imagine if you have a 3 by 3 matrix multiplied by another 3 by 3 matrix, or 4 by 4, or a 4 by 7 multiplied by a 7 by 7. You know, it gets really, really big. Okay, one thing you must remember though is that matrices are not commutative. So when I say commutative, I mean that if you multiply A times B, it is not necessarily equal to B times A. Right, so you have to be careful of that. Well, I hope you found that video useful. Please let me know in the comments below if there's anything you think that I should have added. And I will see you in the next one. Bye.